Now, some of you may be wondering why I'm using a rusty piece of steel, why I didn't turn it down to a smaller size and all that kind of stuff. Well, I first bored out this hole, and I was going to sacrifice a piece of 25mm, turn it down to 20 and do this. And then halfway through I thought, why go through that process? Why sacrifice a piece of 25 when I've got a rusty old piece of 1920mm? And it happened to be that I had stopped at this size, which fitted that rusty old piece. So that's why I'm using that. Now, the reason I'm not worried about it is this all has to go together, drilled, tapped, bolted up, everything, and then after all that's done, including the hardware for the screws, I'll then mount it and just true up the outside edges. So that's why I'm not worried about the rusty piece of steel. My stock is very limited, so I just don't want to waste it. And I've got very little of the 25mm stock left. Alright, what I've got here are the 4 holes. 1, 2, 1 down the bottom, 3, the one over there, 4. These holes represent the location for the force for the cross, the 2 slots. Those slots are for the jaw nuts to travel up and down. They go through there like so. These slots have to be in the middle as best possible between those 4 bosses, the pads. They have to be between the pads. So that's what I'm trying to achieve. One of 2 things. That's the first one. To get those in the right place. Once I get it in the right place, or close enough. Oops, I'll stay back here. I then want to take that out of there. Silly. There's a defect in the housing in the disc there. I need to miss that. So then once I get that roughly in the correct position, I then have to get the front plate to run concentric with the back plate.
So that's a high spot. It's a high spot. That didn't go right. Or did it? Yes, it did. No, it's still got a low spot there.
Unfortunately, both these faces have to still rough cast. And I'm thinking that's causing me some grief here. And I need the 4 holes marked, excuse me, made, so I can turn them into M6s and bolt this plate then to the face plate so I can face off both sides. So just let me continue to play with this. I'll eventually get there. It's getting close. So That's within 2 thou. I can machine this after it's all finished anyhow, but that's in 2 thou, within 2 thou. So I now need to clamp this up because I have to take it off to drill it from that side. So facing off the front plate, doesn't matter which side is, well it does actually, because I've already marked these. This is the back side of the front plate. And I don't know what that noise is, it's only just started. I think I'll just do one more run, 5 thou. That's a nice finish. Bit of a hole there, casting defect up there. No, that's a nice finish. Where am I bolted? I'm bolted there. So that position is where one of the nuts will run. That position. That position and that. So no, that's beautiful. Unlock the saddle. Beautiful, that lock. I know a bloke that made that lock. Works good. So this is the second side. The main face. Yep, they've come up pretty good. I just got to get a smoother finish. I was using the cordless drill for that exercise. That's a lot better finish. I need to dress this up. So So whatever that noise was, it went bang, clunk, and then spat off somewhere. The machine didn't catch on fire, so I'm happy about that. Might be able to file that off. Alright. Well, I found out what the noise was, and this is the plate that goes on the end of the motor shaft to, well, actually the motor shaft pulley goes on the end of that and helps track the tooth belt, you know, to stay on. I just had a look. It's off by about the 16th, so I don't know whether it will happily stay there or not. I'll have to find some screws. Now, this little misadventure caused me a little time back to have to make an aluminium gear, tooth pulley, a drive tooth pulley on the spindle, because the plastic one broke when one of the screws came out and jammed the motor shaft and drive pulley into the cast iron housing. Came out and bang, locked it up. The momentum of what was in the chuck kept going and broke the plastic gear. So this is the second time it's come off. I might have to make a new one. Maybe cut some new drill and cut some new threads, holes in that pulley, if I can do that. Anyhow, that's another day. That clicking noise I had, and then it went bang and didn't hear it anymore. That was this plate that I showed you. I cleaned the plate up. I drilled out the two holes here in the pulley. I drilled it out about 8mm deep. The holes were originally only about 3mm of engagement, so, or 4mm. I drilled it out 8mm, re-tapped it and put long screws in here. And before I put it back on, I realigned the axis of the motor so that the pulley, the belt, by turning it to see whether the belt was walking its way off or not, and it was, and it was probably putting a lot of pressure on here. Plus this belt was too tight. It's better now. So yes, I realigned the motor, drilled these two out deeper, threaded them, and used longer screws, and hopefully I won't have problems with it again. Put it all back together. Back in business. It's all back together. Let's see how it performs. Okay, where is scale? Well, I thought this was going to be a lot easier than what it is. That's better. Well, is milling it easy? No, not really. There's let's think. That's a 10mm cutter. Could have used a 12, but I know my 10mm sharp, and one of my two 12s is blunt. But all right, let's break this down. So that's a 10mm cutter. I'm making an 18mm slot. And it's a total distance of 127. So let's see. I've already had two mishaps with it. It started running up a hill over here. This shifted. It's not a very good setup, but it's all that I've got. And apart from the fact that it came loose. Well, it didn't come loose. I was taking too big a cut. The machine and the cutter was handling it, but the vice wasn't. So I've had to cut the step back on the cuts. So I'm taking a 2.25mm deep and then a 3mm step up. So let's just quickly do the numbers. So once to do the 10, I drop down 3, I come up 3, that's 16, so that's 1, 2, 3, and then I'm going to 18, so a 1mm cut at the bottom, 1mm cut at the top to finish it off. So that's 5 cuts. And it takes 9 2.25mm cuts to get through this 19mm plate. So that's 5 9s are 45 cuts, 127mm cuts. 45 of them to break through. That's only on one of the cross, one leg. And I've got to flip that around and do the other one. So that's 90 times I'm going to do it. As you can see, I've done some up and down preliminary ones at 10mm. I couldn't come down far enough because it's in the vise, obviously. Couldn't go up high enough because the whole setup is too high for it to reach to its height. So I'm going to have to take this out, realign it, and then do that vertical cut as a horizontal cut. So let me crank this up and we'll show you what's going on. Using my trusty drive. And then I run it to the end without the drill, because I can feel the stop. Well, that's now out to 16 millimetres. Okay. I've got to bring it out to 18.
Come up to 4. Tension that.
Okay, let's see what size have we got there now. Seventeen, 18. 0.02 under. No, 0.03 under. That's good. Let's see now. I'll just clean up the ends. You out of here, sweetheart?
Yeah.
I'm just going to clean up the ends. And there we have it. Still got to clean up these ends a bit. They're the ones I just cut, I think. Yeah. Just put the file over them and they'll be right. That'll be that part finished. Okay.